we're asked to sketch the diagram on the axes above. Now it's only worth 2 marks, and it's on the calculated paper. Okay, so we're using our GDCs to do this, so it's y equals x to the power 4 minus 4x cubed. So I need to copy it out of this. Y equals, let's clear this, x to the power 4 minus 4x to the power 3. And I may as well stick the other one in now. So this is an absolute function. So we go to number. So number 1 says abs. So we hit number 1. And then we just type 40 minus 17x. See, it's inside the modulus signs. Okay, so before we graph this, we need to make sure that our window is as it is on the graph paper. So we've got x values from -3 to 5. Oops. And I'm going to go up in 1, so that's what this means. And my y-axis goes from -30 to 200. And I'm going to go up in, let's say, tens. Let's graph that. And then you just need to copy what this looks like onto your graph paper. I'm not going to do that, you can do that. Just make sure that you're taking into account these points here. So make sure it looks like this. So it may be worth marking on here where you think roughly all the values are. So example, -1, -2, -3, 1, 2, 3, 4, 5. That's not awesome, but gives you an idea. Okay, so make sure it does look like that when you do it. We're now to solve this equation. So we have, it's only worth 2 marks, so again it's on the calc paper, we're assuming we're going to do that. This is the first graph that we drew. So we're trying to find out whether the blue graph is equal to 0. So we use our calculate function, and we're calculating the zeros at number 2. And it says here left bound. So I'm going to move this before it hits 0, so I hit enter. Right bound. I'm going to move it to the other side that I think it's going through 0. Enter. Guesses. Enter. Gives us an actual value. Now this is -4.4 e to the -34. This is indicates standard form. So we're assuming this point is 0, 0. So one of my answers is 0. We can see it crosses over here as well, so we need to repeat the process. So second calc 0. So we need to scoot the cursor all the way to the other side. Oops, why has it already got on right bound? Let's do that again. Calc 0. So scoot over. So it has to just be near to the point where it crosses the x-axis. So left bound, enter. Then it has to go to the right, enter. The guesses, and then 0, 4. So our solution would be 4. Find the coordinates of the local minimum point on this graph. So same graph, the local minimum. We know that minimum points are points that look like this, so this is what we're trying to find, but again we would use the second calc. And you see number 3 says minimum. So it says left bound, so again we have the left side of the minimum point. and then the right side of the minimum point. Guesses, and then tells us it's at 3.0008, so obviously that would be 3 and negative 27, so 3, negative 27. Here us to solve this is equal to this. It's only worth 2 marks. You've drawn both of those graphs. If you're solving that one equation is equal to the other, it means where they cross or where they meet. So we can see that they meet in 2 different places. And I just want to know the x values, so we use the calculate function. So second calc, and we're using intercept. Seeing as we're over here, we may as well do this one first. So be close to the point you want to do. That says first curve, so it's on the blue curve. Press enter. It now jumps to the red one automatically. Enter. And this 4.41 is one of them, because we ran to 3 sig fig. And we're going to repeat that. So we need to scoot all the way to the other side. Enter, enter, and negative 2.33.